Hello guys, hope you guys are doing fine. So today we will discuss on a topic which comes under system design, and that topic is on distributed data stores. So as we know, like there are two type of databases. One is RDBMS, another one is NoSQL. Now we need to think like how to scale them. If we consider figure number one, where we can see like there is an app server and a service is responsible to cater the request, whatever coming from the users or end users. And whenever he is catering this request, he is taking help of the information from the database. So he is communicating with the database, and database is giving here response, he's calculating it, and he's reverting it back as a response to the end user. So now the question is, this DB server is fine if you have less amount of requests in your system. But whenever your request gets large in amount, then you need scaling, a proper scaling. And that scaling should be done in service layer or app server layer as well as the DB layer, right? Suppose 1 million request is coming per month, then how we can scale, right? We need to scale both the areas like in the service layer and the DB layer as well. So what are the possible scaling we can have in our plate that we will see? The first one is like the master slave architecture. In the master slave strategies, what exactly happen whenever you have multiple, I mean, here you have multiple instances of DB, right? And in which we can see like we have a master DB, right? And there are a couple of, there are slave DBs as well, right? So any write operation, whatever we do, that we do in master DB, right? In case you want to read, and I mean, frame it in this way, like in case you want to read our application, that is going to happen from the slave DB. So you are actually separating the applications process in two categories. One is your read, another one is your write. So all read operation will be having from the slave DB, you are making it a thumb rule, and all write operation is going to happen in your master DB. So it is going to be the responsibility of some services which will lie over here, that master who are responsible, that they will eventually, they will consistent your slave DB, and that information he will take from the master DB. That means master DB's data is going to be updated to the slave DB eventually, and there will be few services you can assume like that who will be responsible for that synchronousness, eventual synchronousness. You can assume it in this way. Now the question is why it is being designed in this way. Why we are writing in master DB once and slave DB multiple, and doing read from slave DBs, because it has been seen that in many times that our applications, whatever application we do, we normally go with more read operations and less write operations. So that's why we kept it in a separate way. The master DB is going to take all the read operations responsibility, and whatever the slave DBs are there, that will be catering all type of read operations responsibilities. Now the question here, there would be a point, I know that one question is coming in your mind, that this type of system is allowing one feature, and that is that asynchronous updation. This asynchronous updation or upgradation of database is happening over here, that is for sure. Like, you can say like if user wants to access data concurrently, right? Suppose say he has wrote something, he has written something into the master DB, and to access that data immediately, he is contacting one slave DB, right? And in that meantime, if that data has not been updated from master DB to slave DB, then as we are allowing asynchronousness, then there is an issue of inconsistency. Is it true or not? Yes, it's true. This type of system, you get this type of problem. So you have to be cautious, like why to use this type of system. Means if your system doesn't have any problem with eventual consistency, then you can go with that one. I mean, there would be no issues. Absolutely. Okay, now let's talk about the problem what exactly we were discussing earlier, that is an issue of inconsistency. To avoid that problem, there is another technique which we have, so here you can like put this thing in this way, like it's like a master slave stuff. And there is another approach which is coming here as a handy, to get rid of that problem, and that is called sharding. So in case of sharding, the basic assumption, right? The basic assumption is we do not have master slave architecture. We have all of the masters. That means these three databases, you can see, these all having the same priority towards their contribution. They all are same. They are having same weightage, right? So the question is, whatever the data you have, you have split it in 3 instances here in the figure number 3, right? So now this divided into 3 segments. You can see, like, whenever you are divided into 3 segments and you want to find out the data lies in which segment, you need something, and that is going to be a key, and that is called sharding key. Now, what does it mean, AI, JS, TJ? I am explaining that. For this particular example, small example, we have splitted our data, which, say for example, we have a alphanumerical primary key, and that is kind of starts with some letters, starts with some characters. So whatever characters, starting character is had, it got, based on that, it has been decided, like A to I, these characters will, these primary keys, or will the data corresponding to that primary key will go to database number 1, JS will be to database number 2, and TZ will be database number 3. Suppose you have split it into these 3 categories. Now they are all distributed in this case, you can say in 3 databases. Now your question, I know that you have a question, that is like, you will ask, like in former cases, in the cases when we are discussing master slave architecture, we have separated our operations into categories: read operation and write operation. So in this case, will that read and write operation will be having from one database? Yes, that is true. That is going to happen from one database only. And that is why actually, what happened, like these 3, you can say, like the capacity, it is called the capacity because we have split it in 3 categories. So capacity is going to be 3, right? So the capacity is coming over here, and the simple purpose, if you have the sharding key, you can contact the respective database and pull or write, means read or write from in the data, in that database. Absolutely fine, that is going to be. Now there is a service who is going to give you, who is going to, locator service kind of thing, who is actually make you understand that where the database is located based on that, partition key, because it has been partitioned into 3 categories. So in 3, so that's why capacity is 3. Now the question, there is a problem here. The problem is every arrangement has its own positive approaches, and it has got its downside as well. So we cannot get rid of the downside here. There is a problem. Suppose you have the data, the major data is coming, and the major data is lying to I categories. So this database or this database server is having huge load. So in terms, I mean, that means it is called a hotspot. So it will be creating, I mean, there is a situation when you are going with hotspot, right? So the most of data as pushed into this instances, it will have heavier load, and which is not, from design perspective, which is not good. So we have to split AI further. So that is the being an architect or being a designer, you have to take the call that probably that needs, further splitting. We need to split it further, and we need to go with further sharding techniques. So you can split it, for an example, AF and FI based on the load. You have to take that decision. This is a proper scaling approach. This is not a proper scaling approach for sharding. And more importantly, joining data between different nodes needs an extra layer, which I was talking about, that who will actually, integrating, or I mean, that joins that data, right? That layer is called locator service, or any type of service we can assume, which lies between these two layers. And that will be having a network call also, so that will increase your latency, because that is additionally giving some network call. So that is overall today's discussion. We won't make it very long. So we are closing here right now. If you have any comments, you can please proceed with your comments and feedbacks. Thank you so much.